divide rational expressions, we want to make sure that we remember how to divide our numerical fractions and then carry that process across to when we're dividing our rational expressions. So let's first recall what we did when we had numerical fractions and we were asked to divide them. Remember, to divide numerical fractions, we kept the first fraction the way it was, changed the division to times, and flip the second fraction over. So every division question can be rewritten as taking the first number and multiplying it by the reciprocal of the second number. And then we're ready to follow the same process we did when we were multiplying fractions. We've turned this into a multiplication. So remember, to multiply fractions, we multiplied across the numerator and multiplied across the denominator, but we just showed the partial multiplication so that actually we could go and use that attachment of multiplication to continue to factor our numerator and factor our denominator so we could see if there were any common factors that could be removed. So in my numerator, 13 is prime. I'll still write 13 times 14 can be factored down into 2 times 7. In the denominator, we have our first factor of 7 is prime, so we'll leave that. And 52, let's go ahead and write out the prime factorization of 52. Well, 52 is even, it's divisible by 2, so I know 2 divides into it. And if I divide 2 into 52, I get 26 for that other branch. 2 is prime. 26 is still even, so I know that 2 will divide into it. And when I divide 2 into 26, I get 13 for the other branch. 2 is prime and 13 is prime. So 52's prime factorization is 2 times 2 times 13. So I'm going to replace this factor of 52 in the denominator with its factorization 2 times 2 times 13. Now when I look between the numerator and denominator for common factor pairs, I have a common factor pair of 13s that can be removed, a common factor pair of 2's that can be removed, and a common factor pair of 7's that can be removed. Now remember, when we're removing those, we're removing factors of 1 as we go through that. So in my numerator, when all of the factors have been removed, that leaves me a numerator of 1, and a denominator, I had a 2 factor left. So the answer to this division question is 1 over 2, or 1/2. Remember that if your extra factors that are left are in the denominator, you need to make sure you report them in the denominator in your final result for your answer. Well, how can we use that in our algebraic fractions? I see that I have a fraction divided by another fraction. So I'm going to write the first fraction the way it was originally stated in the problem. Change the division to multiplication and take the reciprocal of the second fraction. So I'll write the x minus 12 in the numerator and the x squared minus 9 in the denominator. So now we've written it as a multiplication of the rational expressions, and to multiply, we write the factors across the numerator and the factors across the denominator, remembering that the length of a fraction bar is a grouping symbol, so we need to put parentheses around the start and the finish of each. So I have open parentheses, x squared minus 3x, and there's the end of that fraction bar, so I'll close my parentheses, times, open the parentheses, x minus 12, close that set of parentheses. Now we'll go in the denominator, I have an open set of parentheses, then x squared minus 13x plus 12, close for the end of that fraction bar, and times x squared minus 9. Because when we're multiplying fractions, it's multiply across the top, multiply across the bottom. But because we want to leave our answers in the most simplified form, any of these factors that we have, we want to see if they factor any further. So let's write our fraction bar. X squared minus 3x. I have a common factor of x in each of these terms, So we'll factor out the common factor of x. X goes into x squared x times, and x goes into a negative 3x, a minus 3 times, and close that set. Now, in the second set of parentheses in the numerator, I have x minus 12. I have no common factors numerically, nor variable, and my power is just to the first power on the x, so this factor doesn't factor any further. We're just going to report it as an x minus 12 in the numerator. Now let's go to the denominator. X squared minus 13x plus 12, and that's where that parenthesis closes. There's no common factor all the way through. There are 3 terms, and it's in descending order, and the leading coefficient of your squared term is 1. So I want to see if there's any numbers that will multiply together to create this last number 12, and also add together to get the middle coefficient of negative 13. The numbers negative 1 and negative 12, when you multiply them together, negative 1 times negative 12 gives me a positive 12 last number, and negative 1 plus negative 12 gives me a negative 13 in the middle. So those are the numbers that do that. So that's what I'll put in my binomials. X minus 1, x minus 12. Now let's go to the next factor, x squared minus 9. Well, there's no common factor all the way through. It has 2 terms. The first term is a square, a minus is between, and my last number is also a square. 9's a perfect square. So this is a difference of quantities that are squares, the difference of 2 squares. That factors as, you put in your first slots in both binomials, what would multiply together to get your first term. So an x and an x would give me an x squared if I multiplied them together. And for the last positions in your binomials, you put in the numbers who multiply together to give you this negative 9. So that would be a plus 3 and a minus 3. And those are the ones that would also give me the middle term that would cancel out, and why I only have 2 terms in this expression instead of all 3. Okay, so everything's been factored. I'm ready to remove my common factor pairs. X minus 3's are a common factor pair. And I also have a common factor pair of x minus 12 between the numerator and denominator. But then that's all that removes as common factor pairs. So I have a factor of x left in the numerator. And in the denominator, we have x minus 1 and x plus 3. So we'll write that x minus 1 times the x minus 3. X plus 3, excuse me, in the denominator. So this is the simplified form of the answer to our original division of those rational expressions.